Hello, everyone. I wanted to make a video for you to help you with a few things in the product and quotient rule that we didn't get to. I wanted to show you a few more examples. So we're just going to start with some of these that we didn't get to in the notes. So number 3, v of x equals the quantity 2 plus 1 over x times the quantity x to the 3 halves plus 1. Now, something like this showed up in sections 3.1 and 3.2. And in that section, Achieve encouraged you to multiply this out and FOIL everything out and multiply everything by everything else. And then after you do that, you will have a number times variable to a power plus a number times variable to a power and all of that kind of stuff. And you can apply your derivatives to each of those individually. Now in this section, section 3.3, we have the product and the quotient rules. So we can actually do this by the product rule because there's multiplication happening right in here. Oh, yep. No, there we go. There's multiplication happening right in there. And we have something with x's times something with x's, which says, hey, do the product rule. So to do the product rule, I'm going to call this first one f. I'm going to call the second one g. And the derivative of this entire thing is going to be the derivative of the first times the second as is, plus the first as is times the derivative of the second. And we're just going to do these derivatives. So f of x is 2 plus 1 over x. I need to take the derivative of that. Okay, I know the derivative of 2 is 0 because it's just a number. Now the derivative of 1 over x, I don't have a rule for that. So we have to use algebra to rewrite this. And we will turn 1 over x into x to the negative 1 power. As soon as it's written that way, I can now take the derivative of it. So to take the derivative of 1 over x, I'm going to do the derivative of x to the negative 1, and I'm going to get negative 1 times x to the negative 1 minus 1, which is negative 2 power. So this whole thing is f prime of x, that's my derivative of the first, times the second function as is, x to the 3 halves plus 1. And I'm going to add to that my first function as is, which is 2 plus 1 over x. I'm going to write it as x to the negative 1 again, just because I think that's easier to do algebra with. And I'm going to multiply this by the derivative of the second. The derivative of g of x is going to be 3 halves times x to the 3 halves minus 1 power. That's 3 halves times x to the 1 half. And plus the derivative of 1 is 0. So now we have the product rule here. And so once I have this, I'm just kind of doing the algebra here. So 0 plus all of this is just going to be negative x to the negative 2. And I'm going to have to multiply that by x to the 3 halves plus 1. I'll do that in a second. And then here I've got 2 plus x to the negative 1 times 3 halves x to the 1 half. And that 0 is not doing anything for us. So now I can distribute each of these out. So I'm going to get negative x to the negative 2 times x to the 3 halves. If you're multiplying two things with the same base, you add their exponents. So to multiply these two, I'm going to get x to the negative 2 plus 3 halves. That's negative 4 halves plus 3 halves. That's going to give me x to the negative 1 half. And then I distribute and I get minus x to the negative 2. And then I'm going to add to that. Again, I'm going to multiply this 3 halves x to the 1 half out. 2 times 3 halves is 3 times x to the 1 half. And I'm going to add to that 3 halves times x to the negative 1 plus 1 half power. Negative 1 plus 1 half is negative 1 half. So now I've distributed everything out. And I'm just going to look for like terms here. And I have x to the negative 1 half here and an x to the negative 1 half here. So we can go ahead and combine like terms. And I'm going to get negative 1 plus 3 halves. that's going to give me a positive 1/2 times x to the negative 1/2 power minus x to the negative 2 plus 3 times x to the positive 1/2 power. This is my derivative. And again, you'll get the same thing whether you do the product rule like this or whether you FOIL everything out at the beginning and then take the derivative of each piece separately. Promise you'll get the same thing. And you can practice that if you want. I think that would help you with your derivative rules as well, and some of these exponent rules. These exponent rules are not going away. They're going to be huge for you in this section. So make sure you're comfortable with that. Do extra practice with exponent rules if you need to. All right, so let's come to number 4. Okay, so I have h of x equals x to the third times the quantity 2 times the square root of x plus 1. And I want to evaluate the derivative of this at x equals 4. So really what I'm looking here for is h prime of 4. I'm going to plug 4 into my derivative, but before I can plug 4 into my derivative, I have to find it. So we have to figure out what h prime of x is first. Okay, so to find h prime of x, again, if you wanted to, you could use algebra and distribute that out and then take the derivatives of each piece separately. But because we have something times x's times something with x's, something with x's times something with x's, this says to take the derivative, use the product rule. There's multiplication between stuff with x's in it. This is the product rule section, so we're going to practice using the product rule. I'm going to call x to the third f. I'm going to call 2 times root x plus 1 g, and we're going to rock with the product rule. We've done this a few times, so I'm going to go a little faster now. So I'm going to take the derivative of my first. The derivative of f is 3x squared times the second as is. G is 2 times the square root of x plus 1. And I'm going to add to that my first as is, which is just x to the third, times the derivative of the second. Okay, so to take the derivative of 2 times the square root of x, I don't have a rule for the square root of x. So we have to use algebra to rewrite 2 times the square root of x as 2 times x to a power. What power would you need here? Yep, 1/2. And so now that I've rewritten it into 2 times x to the 1/2 power, I can take the derivative of that. It's going to be 2 times the derivative of x to the 1/2, which is going to be 2 times 1/2 times x to the 1/2 minus 1, which is negative 1/2 power. And then I'm going to add to that the derivative of 1, which is just 0. So you can add 0 here, but I'm not going to include it because if you add 0, that doesn't change anything. And you notice here the 2 times 1/2, this just becomes a 1. So I'm going to go ahead and just make that a little smoother here. And I'm going to call that 1 x to the negative 1/2. Okay, so now we've done the product rule. Now we just have to simplify this. Okay, so I'm going to distribute out my 3x squared and I'll multiply these. Okay, so 3x squared times 2 times the square root of x. 3 times 2 is going to give me 6. X squared times the square root of x is x squared times x to the 1/2. Again, when you multiply things with the same base, you add their exponents. So this is going to be x to the 2 plus 1/2, which is 5/2 power. And I'm going to add to that 3x squared times 1, which is 3x squared. And I'm going to add to that x to the third times x to the negative 1/2. You're going to add your exponents. 3 minus 1/2 is 2.5 or 5/2. And again, notice we've got some like terms here. 6 plus 1 more gives me 7x to the 5/2. And then I still have this 3x squared hanging out. This is my h prime of x function. Just going to box around that. That's my h prime of x. And I'm not quite done because I was asked to find the h prime of 4. I still need to plug 4 into this. So if I want to find the slope at x equals 4, I would plug 4 in here. And what I'm going to get out is 7 times 4 to the 5 halves plus 3 times 4 squared. Well, 4 to the 5 halves, this is 4 to the 1 half, the square root of 4, which is 2 to the 5th power. That's going to be 32. You can put that in your calculator. And again, 4 to the 5 halves, this is the square root of 4. You can either put that 5 inside with the 4. I'm going to put it on the outside so that my brain can do this in my head. The square root of 4 is 2. 2 to the 5th power is 32. I can do it in my head that way. If I had done 4 to the 5th power first, that would be hard for me to do in my head. And then I'm going to have to take the square root of a really big number, which would also be hard for me to do in my head. So that's why I put the 5 on the outside. And then I'm going to get plus 3 times 16. I'm not going to lie, my brain's not going to do that right now. So I'm going to get out my handy dandy TI-30 X2S, and I'm going to make it do this for me. And I'm going to get 272. That means that the slope at x equals 4 is 272. It is real steep at x equals 4. And then just a side note here, if you were asked to write the equation of this function at x equals 4, this would be your slope at x equals 4. You could plug 4 into your original to get your point, and then you would take your point and your slope and plug it into y equals mx plus b. So once you have the slope, you're kind of off to the races finding the equation of the tangent line if you had to do that. Hopefully that makes sense. Okay, so let's do some more. Number 5, if we want to do y equals x to the third plus 3x minus 4 all over e to the x. All right, this time I have something with x's in it divided by something with x's in it. I need a quotient rule for that. So to do the quotient rule, you're going to call the thing on top your f of x. You're going to call the thing on the bottom your g of x. Or if you like my mnemonic aid, the top f of x is high, the bottom g of x is low. Okay. And then once we have named those, our derivative dy dx is going to be low, g of x, times d high, the derivative of the top, which is f prime of x, minus high, f of x, times d low, the derivative of the bottom, that's g prime of x, all over low, which is g of x times itself, or g of x squared. Okay, now we just have to do this. Okay, low, the bottom as is. G of x is e to the x, times f prime of x, the derivative of the top, that's d high. The derivative of my numerator here is 3x squared plus 3. Again, I'm going a little bit faster with our derivative rules. Hopefully you're starting to feel more comfortable with those. Minus high, f of x, the top function as is, times d low, the derivative of the bottom. The derivative of e to the x is e to the x. And this is going to be all over e to the x squared. Okay, and then from here to simplify, because I've got polynomials all over the place, I'm going to distribute these e to the x's. Or actually, let me, instead of distributing these, so you could distribute those e to the x's out, but I'm actually going to take a different route here. Do you see that there's an e to the x in both of these? I'm going to go ahead and just factor an e to the x out on top right away. I think that'll make this a little faster. So if I take an e to the x out of everything on top, when I take it out of this first part, I'm going to get 3x squared plus 3. And I'm going to subtract from that what I get when I take an e to the x out of the second part, which is going to be x to the third plus 3x minus 4. And I'm going to have e to the x squared on the bottom. And notice because I'm subtracting this entire thing, I'm going to have to distribute that negative. I'll just come over here and we'll have e to the x times 3x squared plus 3 minus x to the third minus 3x plus 4 all over e to the x squared. And then this e to the x cancels one of these e to the x's. And do I have any common factors on top or common like terms? There we go, like terms to combine. I have a number and a number, so we can combine that just a little bit. And it's going to be 3x squared minus x to the third minus 3x plus 7 all over e to the x. The perfectionist in me wants to switch these and put it in descending order, but it honestly doesn't matter. So let's just put a box around it and call that good. And that is our final answer. That is our dy dx for this original fraction function. That's the quotient rule. You can use that anytime you have a function with something with x's in it divided by something with x's in it. We did number 6 in class. Again, you're going to write that as 1 over e to the x and apply the quotient rule to that. Your answer there will be negative e to the negative x or negative 1 over e to the x. But again, you can just apply the quotient rule to that, and I can let you rework that out, or that you can find that in the completed notes. Okay, let's move on to number 7. This one is extra mean because we have stuff with x's in it times stuff with x's in it divided by stuff with x's in it. This is a lot of stuff, guys. How do we figure out where to start? Well, to figure out what to apply first, you're going to look at the structure of the problem. Overall, this is something with x's in it divided by something with x's in it. If you're not sure how to see that, I want you to think about what you would do if you plugged a number in for x. If you plugged a number in for x, you would multiply it by 4 here, and you would take e to the first power here, and then you would multiply those. And then you would square that number on the bottom and add 1 to get a number down here. The very last thing that you would do to get a number out of this, if you plugged something in, was take the number that you get out on top divided by the number that you get out on the bottom. That final operation by order of operations tells you the structure of the problem. That last operation is division, which means the structure of this problem is something with x's divided by something with x's. So that says to us, quotient rule. The structure of this problem is division. I'm going to apply the quotient rule to this. Okay, so don't panic. We're going to call the top f of x. We're going to call the bottom g of x. And actually, instead of calling f of x and g of x, I'm going to do low and high here because I think we'll get less confused later. So hopefully you're okay with me doing this. If you don't like the low and the high, go ahead and call them f and g. We'll have another f and g separate in a little bit, so you'll have to kind of separate that out in your mind, but it's okay. We're going to deal one thing at a time. Okay, so our high is 4x times e to the x, and our low is x squared plus 1. So we are going to start with the quotient rule, and the derivative of this entire thing is going to be low, which is x squared plus 1 as is. Now we're going to have to take that and multiply by the derivative of the top. Oh, geez, guys, to do the derivative of the top, we're going to have to do the derivative of something with an x times something with an x. That's going to require a product rule. So I'm going to hit the pause button here right now, and I'm just going to say, oof, I'm going to have to do the derivative of this, and I'm going to do it in a second when my brain can focus on that and not lose track of the quotient rule. So I'm going to pause, and I'm going to have to come back to that. So this is low, d high, minus high, the top as is. I don't have to hit the pause button because I don't need to take a derivative there. And times d low, the derivative of the bottom. The derivative of x squared plus 1 is 2x. And this is all going to be over low, the bottom squared. Okay, so we've done the quotient rule, right? But we didn't quite finish it because we hit the pause button here. All right, so now let's go back in and figure out how to take the derivative of 4x times e to the x. So I'm going to call the first one f, right? 4x is my f of x, and I'm going to call e to the x my g. So when I do the quotient rule, I'm going to do the derivative of the first, f prime of x. The derivative of 4x is 4 times the second as is. E to the x is my second function as is, so I can leave that there. And then I'm going to add to that the first function as is, f of x. That's 4x times the derivative of the second, that's g prime of x. The derivative of e to the x is e to the x. And now I have completed the product rule inside this quotient rule right here. If you could have done that immediately when you did D high, you can do this in one step, but it's a lot to keep track of. So if you need to hit the pause button, just go ahead and say, woof. I'm going to just say I need to take the derivative of this, and I'm going to come back later when I can focus on it and my brain will do it right. So hit the pause button if you need to hit the pause button. No big deal. And we are here. This is my derivative. Now we just need to simplify this. Let's see. I'm going to start by distributing this x squared plus 1 here. So I'm going to get, I'm going to put the 4 e to the x out front and then multiply by that x squared plus 1 plus this other one is 4x e to the x times that x squared plus 1 minus 4x e to the x squared. So I distributed this top part and I multiplied these two. And I have this all over x squared plus 1 squared. And now just to simplify a little bit, it's not really going to simplify. I don't have any like terms on top because I could distribute each of these into the x squared plus 1s, but I don't think we want to do that. If I really wanted to, I have a 4 e to the x in all of these. 4 and an e to the x. I could factor that out if I wanted to, but again, I don't know that that would really do much for us. If I took it out of the front part, I would have x squared plus 1, and then I would add to that what I get when I take it out of the middle. If I take the 4 and the e to the x out of this middle term, I'm going to have x times x squared plus 1 left. Minus, if I take the 4 and an e to the x out, I have x e to the x left over there. And this is all going to be over x squared plus 1 squared. And the only thing here is I'm going to make sure I don't have any like terms in there. 4 e to the x is x squared plus 1 plus x to the third plus x minus x e to the x all over x squared plus 1 squared. Yeah, I don't have any like terms. I really didn't get any simpler here. So because nothing simplified or combined, I would take any of these because they are algebraically equivalent. Nothing got any simpler. And nothing could really combine. Nothing canceled. It was just factoring things out or multiplying things. So I'll take any of those, and achieve will as well. But I also wanted to go through some of that algebra because in a few weeks, it'll be helpful for us to be able to do that kind of algebra and move things around. Because even though this isn't necessarily simpler, it might be a little easier for us to work with than this thing up here. Um, and we might need to do that. So I'm just kind of showing you some algebra that we might do later. But as long as nothing combines or simplifies, you're good. So you can do a product rule inside a quotient rule. No big deal. You've got this. What if you have something really scary like this? M of x equals e to the x times the quantity 3x plus 1 times the quantity 2x minus 7. What if I have something with x's times something with x's times something with x's? There's too many things here. Okay, so to do this, what you're going to do, because I have a bunch of things being multiplied, I'm definitely going to need the product rule. Hopefully that makes sense to you. So I'm going to have to apply the product rule. But the way the product rule works is that we have two functions. We have an f and we have a g. We can't have more than just two functions to apply the product rule. So what I'm going to do is I'm going to lump some of these together and I'm just going to make one f of x and I'm going to make one g of x. So this will be f of x times g of x, and I can apply our product rule just like normal. Okay, so now when I do a product rule, I'm going to do the derivative of the first. You're going to say, woof. To do the derivative of f of x, my first function, I need to take the derivative of something with x's in it times something with x's in it. That's another product rule. This is going to be a product rule inside a product rule. And my brain might struggle with that. So I'm going to hit the pause button and I'm going to say, okay, I'm going to take the derivative of this in just a minute when my brain can focus on that. So for right now, the derivative of that, whatever that's going to be, is the derivative of my first. I'm going to multiply that by the second function as is. And I'm going to add to that the first function as is, which is e to the x times 3x plus 1 times the derivative of my second function. The derivative of g is just 2. And now I've done my overall product rule of f times g. But I hit the pause button. I'm not quite done. Now I have to come back here and actually work out what the derivative of this thing is. Okay, so now we need to come back and do the derivative of this. So to do the derivative of this, I'm going to call the first one f and the second one g, and I will do my product rule inside here. Again, product rule says I'm going to do f prime, the derivative of the first. Derivative of e to the x is e to the x times the second as is, 3x plus 1, plus the first as is, e to the x, times the derivative of the second. The derivative of 3x plus 1 is just 3. So now this is the derivative of this whole thing by the product rule. And now I have everything else still hanging out here. So I'm going to have that times 2x minus 7. And I'm going to add to that e to the x time, I'll put 2 out in front, 2 e to the x times 3x plus 1. And then from here, we can start to simplify a little bit. Again, I see that an e to the x will come out of everything. So I'm going to make my life a little bit easier and take that e to the x out of everything to make my life a little bit easier. And at the same time, this is going to distribute to each of these. So when I take an e to the x I'm going to have a 3x plus 1. And from the distribution, I'm going to get a 2x minus 7 with this one. And then I'm going to add to that. Again, I'm taking the e to the x out of this middle one. So I'm just going to have a 3 left there times one of these, 2x minus 7. And I'm going to add to that, when I take an e to the x out of this, I'm going to have 2 times 3x plus 1. And then from here, all of this is polynomials. So we can just go ahead and rock through all of the distributions. So I'm going to FOIL this. 6x squared minus 21x plus 2x minus 7. I'll distribute the 3 plus 6x minus 21. I'll distribute my 2 plus 6x plus 2. All of my distribution. And then from there, I'm going to look for like terms. So I've got x's and x's and x's and x's. Negative 21 plus 2 is negative 19. Plus 6 is negative 13. Plus another 6 is negative 7. So that's going to give me a negative 7x. And do I have any other like terms? I've got constants. So I've got a 7, a negative 21, and a 2. Negative 7 minus 21 is negative 28. Plus 2 is negative 26. And I still have the 6x squared here. I think that's everything, right? Yep, everything is combined, and I still have my e to the x out here. That is my derivative. Product rule inside a product rule. Whew. Again, hit the pause button if you need to. There's no shame in the pause button. It helps your brain focus on one thing at a time so you don't screw it up. Sometimes when you're doing product rules inside of product rules, it is very difficult to keep track of which rule you're inside of and then where to keep going in the outside rule once you finish the inside rule. So the pause button lets you focus on the outside rule before you evaluate the inside rule. So we could do product rules inside quotient rules. We could have quotient rules inside of product rules. We can have product rules inside of product rules. We could have quotient rules inside of quotient rules. We won't make you do quotient rules inside of quotient rules. That would be extra mean and gnarly, and we won't do that. So for now, just start practicing these rules, get comfortable with them, know them, love them, and fight through it one thing at a time. Hit that pause button if you need to. I hope this was helpful for section 3.3. Have a lovely day, and I will see you next time.